Hi everyone, welcome to the presentation of paper 143 titled Addressing Out of Distribution Label Noise in Webley Label Data. My name is Paul Albert. I'm going to present on behalf of my co-authors Diego Ortego, Erica Razo, Noel O'Connor and Kevin McGuinness. We are from the Insight SFI Center for Data Analytics at the Dublin City University in Ireland. I'll start with the motivations for this paper, and we tackle here web crawl datasets, meaning that these image datasets have been created using search engine on web data. The main advantage of building a dataset this way is that it's very time efficient to do, but on the other hand, you will gather images that do not belong to your data distribution. So our first contribution of our paper is to quantify the amount of noise that you will expect in these web crawl datasets and to classify the nature of this noise. So we do a manual annotation of 3 random subset of 2000 images from the mini WebVision dataset, which is a web crawl dataset. And we observe then that 70% of the images are clean, meaning they are in the distribution and correctly assigned to the correct category. 5% of these images are in distribution but noisy, meaning that they are belong to the data distribution, but they are assigned to the wrong category. And finally, we observe 25% of out of distribution samples, meaning these images do not belong to our data distribution. To deal with this duality of noise in web crawl datasets, we propose a new metric, which is named the collision entropy of the interpolated label, where we look at the interpolation, linear interpolation between the ground truth label and the prediction of the network. And this allows us to then observe 3 modes in our entropy distribution, which the first one of which is the high confidence clean mode, meaning the sample is corrected to the right category and the confidence of the network is great. Second, we have a high confidence in distribution mode, which is separated from the clean mode by the pivot point. And high confidence in distribution, meaning that the network is very confident in its prediction, but the prediction is different from the ground truth label. And finally, we have on the right the out of distribution mode, which is all samples that have a very underconfident prediction. Using these 3 modes, we are able to then first capture the clean samples, which are before the pivot point. And we then have 2 other modes that we capture using the beta distribution model, which captures first on the left the in distribution mode and on the right the out of distribution mode. This allows us to propose an algorithm titled dynamic softening for out of distribution samples, which perform a dual correction. The first one being in distribution, where we use a pseudo labeling approach, where the prediction of the network is substituted for the ground truth label. And second, we have an out of distribution softening, where we aim for the label of an out of distribution sample to be as close to a uniform distribution as we are of its out of distribution nature. A few words of conclusions and some results. We showed in this paper that the label noise in web crawl datasets is both in distribution and out of distribution, with the latter noise type being the predominant one. We introduce a new detection metric, which is capable of capturing the in distribution and out of distribution samples separately in web crawl datasets. And we propose DSOS, which improves over state-of-the-art approaches on both synthetic, we'll have to see in the paper for these results, and real-world noisy datasets. I have a table at the bottom of the slide here on the mini WebVision dataset. Some future work for this would include using out-of-distribution images to improve the convergence of the network, either using them to augment the in-distribution samples or using an unsupervised learning algorithm to make use of these out-of-distribution examples. Thank you for your attention. I'll be happy to discuss this at the poster session.